my name is Yi Yuan. I am a sophomore year student in chemical engineering here at the University of Michigan. Over this summer, I'm working with Dr. Fogler and PhD student Mark Jen on a project about wax precipitation. Today, I'm going to share a little bit about my SURE program experience.
Wax precipitation is a key problem in crude oil production. The wax components in the crude oil can precipitate and deposit in pipelines, potentially reducing flow efficiency and causing other problems. To solve the problem, we need to understand the thermodynamic properties of wax at static conditions. Wax precipitation curve is an important parameter to understand the wax thermodynamics. It can tell us first at which temperature the wax starts to precipitate and how much wax will precipitate at a particular temperature. In the industrial practice, DSC, differential scanning calorimeter, is often used to measure wax precipitation curve. DSC can automatically generate a heat flow curve for the testing oil sample. The cumulative heat release during wax precipitation process can be measured by integrating the enclosed area of thermogram and the baseline in DSC. To get wax precipitation curve, the amount of wax precipitated is equal to the cumulative heat released divided by the heat of crystallization. In previous practices, all wax precipitation curves were derived from the assumption that the heat of crystallization is 200 joules per gram. This is not an accurate assumption because different wax compositions have different heat of crystallization, and heat of crystallization of wax can also change with temperature. The goal of my project is to use a thermodynamic model to improve DSC data processing. My research can be divided into 3 parts. The first part of my research is to conduct DSC tests to get heat flow curves from different oil samples. I actually have several problems while doing the experiments. The first problem happened when I transferred the oil sample from the hot vial to the DSC pan. I noticed that the wax was about to precipitate when it touches the cold pipette, and I could see the cloudiness inside the pipette. What I have to do is to transfer the wax immediately from the pipette to the pan, so that no significant amount of wax would be left inside the pipette. Another problem I found during the experiment is that the temperature scale of DSC is not accurate. It suggests that the temperature shown in DSC may not be the real temperature. To solve the problem, I measured the melting temperature for indium and found that the measured temperature is 2.5 Celsius degrees lower than the certified indium melting temperature from NIST. Therefore, all results from DSC should be added 2.5 Celsius degrees to their temperature scale. The second part of my research is to run simulations with a thermodynamic model. Initially, given the wax composition, the model only functions to provide the theoretical wax precipitation curve for an oil model. My job was to update the code and allow the model to output other key information we need. For example, we need to know how heat of crystallization of wax can change with different temperature. Using an estimation of molar averaged heat of crystallization, the updated code can now tell the heat of crystallization as a function of temperature. Now, in the last part of my research, after getting heat flow curve from DSC and thermodynamic information from simulation, I can try to improve DSC data processing by converting heat flow curve to wax precipitation curve. Assume dt is equal to 0.5 Celsius degrees. The amount of wax precipitated at each temperature decreasing 0.5 Celsius degrees can be calculated as the heat released at each temperature divided by the corresponding heat of crystallization. As a result, cumulative wax precipitation curve can be generated. In the chart, the blue curve shows the theoretical wax precipitation curve generated by the thermodynamic model, and the green curve shows the wax precipitation curve generated after improving DSC data. Now, combining the data from thermodynamic model, the wax precipitation curve looks more similar to the theoretical wax precipitation curve.
There are actually a lot of problems in my research, and I didn't have enough time to improve my results, and test more oil samples before the program was over. Overall, I think Sure program is a great experience for me, and I learned a lot of useful skills. Thanks for watching my video. Bye.